Alright, this is the Unit 4 review. These are all going to be test prep questions, so they're questions that are likely to be on the test. Question 1 says, eager rock fans enter a line to buy tickets to see a renowned band, Sir Isaac and the Newtons, at a rate modeled by the function e of t equals 512.7 e to the negative 0.173 t, where e of t is measured in people per minute and t is measured in minutes. On the interval 0 is less than or equal to t, which is less than or equal to 30. Find e prime of 22 and using correct units interpret its meaning. So firstly, to find e prime of 22, it's calculator active, so you just do it on your calculator. But if I do it on my calculator, I'm gonna get, or e prime of 22, I'm gonna get negative 1.972. And then the units are people per minute, so it's people per minute squared. People per minute squared. Alright, and then for our meaning, we can say the rate at which people are entering the line to buy tickets is decreasing by 1.972 people per minute squared. And then you can say at 22 minutes if you want, any 22 minutes. At 22 minutes, the rate at which people are entering the line to buy tickets is decreasing by 1.972 people per minute squared. Alright, number 2 says, the graph below shows the velocity v of t of a particle moving along the x-axis and can be defined by a continuous linear piecewise function over the interval 0 is less than or equal to t, which is less than or equal to 9. Know that v prime of t equals 0 from 3 is less than 4, or 3 is less than x, which is less than 4. So for the graph, it's just this one. So on which interval does the particle moving left? Well, this is a velocity function, so the particle will be moving left when the velocity is negative. So from 0 to 2, so let's 0 to 2.9, I'm going to say about 1.9, from 0 to 1.9, and then the velocity is also negative from 6 through 9, so 6 through 9. And then for our justification, we can just say because v of t is less than 0. And same for part B, over which time intervals is the particle speeding up. So to check when it's speeding up, we need to check if the velocity and the acceleration have the same sign. So let's start from 0 to 1.9. From 0 to 1.9, it's negative, so that means the velocity of negative. V of t is negative, less than 0. And then, but the acceleration is positive because it has a positive slope. So a of t is greater than 0. So this means since they are different signs, the velocity is the speed is actually slowing down. The speed is decreasing. Okay, let's look from 2 to 3. So from 2 to 3, we can see it has a positive slope and the velocity is positive. So the velocity is positive and it has a positive slope, meaning the acceleration is positive. So 2 to 3 would be when the particle is speeding up. So we can say from 2 to 3, 2 to 3, and then from 3 to 4, even though the velocity is positive, the acceleration is 0, which means when the acceleration is 0, the particle is neither speeding up nor slowing down. So we can't come to any conclusions from that. So from 4 to 6, we can see the velocity is positive, it's above the x-axis, but the slope is negative, which means the velocity is positive, but the acceleration is negative, which means the particle is actually slowing down there. And then from 6 to 8, the velocity is negative because it's under the x-axis, but the slope is also negative, which means the velocity and acceleration are both negative, which means that's a good answer too. Union 6 to 8. Alright, and then lastly from 8 to 9, we can see the velocity is negative because it's under the x-axis, but the slope is positive because it's going up. And since they're different signs, since the acceleration is positive but the velocity is negative, we can say it's slowing down there. So then, over which time intervals is the particle decreasing? We can just say from 4 to 6, because from 4 to 6, it has different signs. From 1 to 2, it has different signs. And then from 8 to 9, it has different signs. So we're going to go ahead and say the speed is decreasing from 4 to 6. 4 to 6. Or let's do 0 to 2 first. 0 to 2. And then 4 to 6. And then from 8 to 9, the velocity is negative, but the acceleration is positive because it has a positive slope. So that means they have different signs, so that's also a good answer. So union 8 to 9. So those are our 3 answers. For our justification, we can just say because velocity is negative and acceleration is positive, or vice versa, depending on what it is. Let's go on to number 3. If square root of x plus y equals 6 and dy over dt equals 2, find dx over dt when x is equal to 4. So first we're going to differentiate this with respect to time. The derivative of square root of x is 1 over 2 root x, but since we're differentiating with respect to time, we have to multiply by the derivative of x, which is dx over dt. The derivative of y is dy dt, so plus dy over dt. And then 6, the derivative of 6 is just 0. So we're trying to find dx over dt, so let's get it to one side. So dx over dt, and then we still have it multiplied by 1 over 2 x. And then plus dy over dt, we're going to subtract that to the other side. So that's going to be equal to negative dy dt, which we know is equal, which is dy dt is 2, so we can say negative 2. And then we know x is 4, so we can plug in 4 there. So this will actually just be 1 over 2. The square root of 4 is 2, so 2 times 2 is 4. And then we multiply 4 on both sides. We get dx over dt equals negative 8. Alright, let's keep on going. A kite is flying at a height of 40 feet. A child is flying it, so it's moving horizontally at a rate of 3 feet per second. If the string is taut, at what rate is the string being let out when the length of the string released is 50 feet? Alright, so let's start by what we're given. We're given that the kite is flying at 40 feet. So this will always be 40 no matter what. It will never change. A child is flying it, so it's moving horizontally at a rate of 3 feet. So this is increasing by 3 feet, so let's write that down. Dx over dt equals 3. If the string is taut, at what rate is the string being let out when the length of the string is released at 50 feet? So we need to find dz over dt when z is 50. So because z is the length of the string. So we need to find dz over dt. So I'm just going to put a question mark when z equals 50. Alright, so first let's make a correlation equation between all 3 of these variables. So we can just use Pythagorean's theorem. We have x squared plus 40 squared equals z squared. And then I'm going to take the derivative of both sides with respect to time. So we get 2x dx over dt plus equals, the derivative of 40 squared is just 0 because it's a constant, and then the derivative of this is 2z dz over dt. Alright, so now let's plug in what we know. We know that dx over dt is equal to 3. We don't know where x is, so let's solve for x really quickly. We know we need to find x when z is 40, so we have x squared plus 40 squared equals 50 squared. And if you know your 3, 4, 5 triangles, then you should know that this is 30. But if you don't, we can work it out. We have x squared plus 1600 equals 2500, and then x squared equals, what's that, like, that's 900, so it's x equals 30. X equals 30 as our answer. So 2 times 30, dx over dt we know is 3, equals 2 times our z value, which we know is 50, dz over dt. Alright, let's move everything to one side by dividing both sides by 2 times 50. So 2 times 30 times 3 over 2 times 50 equals dz over dt. So obviously if this is a calculator portion, you can just plug this into your calculator, but if it's not, you could make it easier by canceling out the 2's. 30 times 3 is 90. 90 over 50 is 9/5, so dz over dt equals 9/5 as our final answer. Alright, a spherical snowball is being made, so the volume is increasing at a rate of 8 cubic feet per minute. Find the rate of change at which the radius is increasing when the snowball is 4 feet in the diameter. So I'm going to copy that and paste it down here so we can do it. We can get a little bit more room for this problem. So the volume of a sphere is V equals 4/3 pi r cubed. We know that the volume is increasing at a rate of 8 cubic feet per minute, so dV over dt equals 8. Find the rate of change at which the radius is increasing. So we're trying to find dr over dt, and that's a question mark, when the snowball is 4 feet in diameter, which means the radius is equal, radius is half of the diameter, so the radius is equal to 2. Alright, now let's start. We're given our equation to differentiate. Let's differentiate that. So the derivative v with respect to time is dv over dt. The 4/3 pi is just a constant, so we can take that out of the derivative. And then here, I'll just do it here just to show you all my work. D over dt of 4/3 pi r cubed. We can take the 4/3 pi out of the derivative because it's a constant. So 4/3 pi times the derivative with respect to time of r cubed. The derivative of r cubed is 3r squared. And then because of the chain rule, we have to multiply it by dr over dt. To simplify this, the 3 in the denominator cancels out with 3 in the numerator, so we get 4 pi r squared dr over dt. So that's what we get here, 4 pi r squared and then 4 pi r squared dr over dt. So now we know that dv over dt is 8, so let's go ahead and plug that in. And we know that r is equal to 2, so we can also plug that in. So 8 equals 4 pi, 2 squared is 4, and dr dt. I'm going to divide both sides by 4 pi times 4. 4 times 4 is 16, so we have 8 over 16, which is 1/2. And then divide both sides by pi, so we have 1 over 2 pi equals dr over dt. And our units is feet per minute, so since the units of the volume is cubic feet per minute, this is the radius, so it's only one dimension, so it's just going to be feet per minute. So 1 over 2 pi feet per minute as our final answer. There we go. Alright, number 6. Sand is being dropped in a conical pile at a rate of 10 cubic meters per minute. If the height of the pile is always twice the base radius, at what rate is the height increasing when the pile is 8 meters high? So let's break down what we got. Sand is being dropped at a rate of 10 cubic meters per second. That means the volume of the cone with the sand is increasing by 10. So like, let me just draw out what the sand pile could look like. So it would be like that, right? So this is the height, and then this would be the radius. So the volume of the cone is increasing by 10 because more sand is falling on it. So we can say dV over dt equals 10. If the height of the pile is always twice the base of the radius, at what rate is the height increasing when the pile is 8 meters high? So we're trying to find the rate of the height, so dh over dt. dh over dt, I'm going to say that's equal to question mark. And we're trying to find that when the pile is 8 meters high, so when h is equal to 8. So now we have, it says the height of the pile is always twice the base of the radius, so I'm just going to write that down, h equals 2r. And then if I solve for r, which I will need to later, I get r equals h over 2. Alright, now we have this formula, let's go ahead and differentiate it. We get dv over dt equals, I'm going to substitute the r, I'm going to substitute h over 2 in for r so we don't have to deal with radius, because there's nothing that tells us about the radius in this question, so I only want to deal with the height. So let me first substitute h over 2 into r here, so v equals 1/3 pi times h over 2 squared times h. I'm going to go ahead and simplify that, so 1/3 pi h squared times h is h cubed, and then over 2 I can just turn this over 3 into over 6. Alright, so now I can differentiate that. That's a lot easier to differentiate that. Let me move this and move this. So, to take the derivative, dv over dt equals 1/6 pi. And then this can be taken out of the derivative, and we're just taking the derivative of h with respect to time. The derivative of h cubed is 3h squared, so I'm going to put the 3 here. And we have h squared dh over dt. Alright, so now the 3/6 simplifies to 1/2. So we have pi over 2. And then h, we can plug in 8. So we have dv over dt equals, and we know that dv over dt is 10. So I'm just going to plug that in right now. We get 10 equals 1/2 pi times 8 squared dh over dt. And then, and then h squared is 64. 64 over 2 is 32, so 10 equals 32 pi dh over dt. And then divide both sides by 32 pi dh over dt equals 10 over 32 pi. And that's our answer. If we want the units, we have meters per minute. So dh over dt, meters per minute. And that's our answer. Alright, let's keep going. This is the last one I'll do. The volume of the cube is increasing by 10 cubic centimeters per minute. Find the rate of the surface area is increasing when the side of the cube is 5 centimeters. Okay, so we're given dh over the volume of cube is increasing by, here, I'm going to screenshot this and move it over here so we got more space. Alright, the volume of a cube. Okay, so dv over dt equals, and it's increasing by 10. Find the rate of the surface area is increasing when the side of the cube is 5 centimeters. Okay, I'm going to use A for surface area, and I'm going to use S for side. So surface area is equal to 6 times the side length squared. Because if the side length of a cube would give us the, so if I were to draw out a cube, I'm going to try my best. So this length, it would be s, this length would be s, this length would be s squared. There's 6 of these sides, so the surface area would be 6s squared. Alright, so that means that first, let's look at the rate of change of the volume. So volume is equal to side length cubed. So if we just derive that, we have dv over dt equals 3s squared ds over dt. And now we can plug in our value of 10, so we get 10 equals 3. For our side length, when the side of the cube is 5, so s equals 5. So 3 times 5 squared ds over dt, ds over dt. And to solve for ds over dt, we get 5 squared is 25, 25 times 3 is 75, so we get 10 over 75, which is 2 over 15. That's 5. 2 over 15, which is ds over dt. Alright, so now that we got ds over dt, we need to use this to find the rate of change of the surface area. So now let's go ahead and differentiate this. So we have surface area equals 6s squared. If we differentiate this, we get dA over dt equals 12s, and then ds over dt. Now we actually know what ds over dt is, and we know what our side length is, so I'm just going to plug all that in. dA over dt equals 12 times 5, and then ds over dt is 2/15. So then that's 12 times 5 is 60, 60 over 15 is 4, 4 times 2 is 8. So dA over dt equals 8, and then this is area this time, so that's 2 dimensions, so it's going to be centimeters squared per minute as our final answer. Alright, I hope you guys enjoyed that, and you guys are going to do great on the test.